Hello, my name is Clemens. I'm the CTO of Persival, and today I'm going to talk about the ASAM OpenMATERIAL 3D standard and specifically about the material side of things. So in my last videos I talked a lot about geometry, that's the 3D part of the standard, and today I'm going to go into the material side of things. So let's jump right in and have a look at the documentation. So the standard, as you already know, is split between geometry and materials. And let's have a look at the materials section. In the standard, the material properties are defined in individual JSON files. And these files contain the actual material properties. There's two kinds of files. So there's the general material data file. It's called xomp, so Open Material Property File. And then we have specialized lookup tables for bigger amounts of data. I'll show you in a minute what that means. And this data format allows you to store actual physical material properties that are wavelength dependent. So for a lidar sensor, you need different material properties than for a radar sensor, for example. But even for one sensor technology, if we look at lidar, you have different wavelengths. So a 905 nanometer lidar will behave differently when it interacts with materials than a 1550 nanometer lidar. And this is just one application example of why we need these physical and wavelength dependent material properties in automotive simulations or any sensor simulations of that kind. All these files are JSON files, so they're just plain JSON files, and that's why we have schemas to define them. Every type of these material files, first of all, has metadata. So every material has a name, it has a description, it has a unique identifier. So you can build up large databases of materials and identify each of these materials and also search for them. We also have in the metadata things like copyright and license information, author information, so you know where this material comes from and if you can actually commercially use it in your application. And then we have the actual material properties. In the general material schema, we have more general properties like surface roughness, like elasticity, density, and these kinds of properties, all defined in a physical way, so they all have a physical unit of measurement that is clearly defined and that can actually be measured in a real material. And what we also have here is references to lookup table files. So you see that here we have this property electromagnetic property URI. And the URI is basically a link to another file. And that's what I was talking about before. Those are the second type of file. If we go back here, we have the xomp files. And then we have the xompt files for property lookup table. And we have different kinds. The first one I mentioned is the electromagnetic properties. So that's here you have basically a table with different columns. And first of all, you have what I talked about, the wavelength dependent. So you can say what wavelength this property belongs to. And we also have other dependencies like temperature, humidity, and then you have the actual properties. So in this case, electromagnetic properties, permeability and permittivity as a complex number. And then it goes on, it's very similar for the other ones. We have optical properties. This gets the complex index of refraction that's used a lot for optical simulations like lidar and camera. And next to these physical properties, we also have properties that can be measured in a different way, like the BRDF. The BRDF stands for bidirectional reflectance distribution functions, And that's widely used in computer graphics and in rendering in general. And it's also used a lot in the simulation of perception sensors. And this is a lookup table, again, wavelength dependent, that defines for which incident angle going onto the material and which exit angle in horizontal and vertical, which reflection value you have per solid angle of observation. And this is what we have in a BRDF. And you can store that for each individual material. And this really enables you to use either complex material models that are not real-time capable. You can run them offline and store the BRDF data from these complex models into the lookup tables and use them in a real-time simulation. Or you can use measurements to measure these properties. And we at Persival have a measurement device. We've built one for lidar. So you see here we have two individual arms that can be moved individually. One has a laser on it and the other one has a detector. And the detector and laser can be swapped out for different wavelengths. And then these arms move over a surface and do their measurements, measure their reflectance. You can see a simple demo video here. Moves in increments over a surface and moves individually the laser and the detector. And what you end up with is these kinds of characteristics. That's exactly what's stored in the OpenMATERIAL 3D BRDF lookup table. So you have a sender angle and you have a receiver angle, and you get the BRDF value out of that. And we have two examples here. This is a rather specular material. So you see this ridge here, where the receiver angle is directly opposite from the sender angle. So you have a mirror-like reflection there. And contrary to that, a rather diffuse material that kind of scatters the incoming light in all kinds of directions. So for one sender angle, you have a lot of power at different receiver angles. But also for these kinds of materials, it can be, so it's in reality, materials are never either or. It's always a combination of both. So you see also here for this rather diffuse material, you have a specular tendency at very high angles. So if you look at the material from basically a horizontal angle, you still have a high specular tendency here. And we can measure that with our reflectivity measurement device and output that into these kinds of tables. And then they can be read in the simulation. And this way you have a very realistic behavior of your signal propagation in the environment. That's it for today. In my next video, I will show you how to actually combine the materials or link these material properties that are defined to the geometry and how to access that in the simulation. So stay tuned for that. If you have any questions, feel free to drop a comment below, and see you next time.